Solving radical equations. So the first thing we're going to talk about is the exploration from last class. We had a 20-story set of buildings that were 25 feet across, and we had to find the beam at the top, how thick it was. And they give us that the width of the beam has to be 2 feet to accommodate the cart that rolled across. And so W is the width. The cart weighed 855 pounds, and the worker weighed, not cost, 250 pounds. Not always, but you have to assume most of the workers, or the maximum worker that's probably going to work there, the average is 250 pounds. So then they give us this equation, S equals KWD squared over L. And the question is that they ask us is, if the thickness of the beam was 6 inches thick, is this thick enough to accommodate a safe load of the cart and the worker? Is this enough thickness to handle the weight? So then they tell us, explain what the equation is. S is the safe load, K is a constant, which they tell us is 576. W is the width, D is the thickness, and L is the length across. Now, most of you probably, to solve this, you just took the values of that were given to you in the problem and just substituted them in and saw if one was bigger than the other. If you did this method, you would have wanted the right side of the equation to be bigger than the left side, because you want the thickness that they give you to be bigger than the load that we're trying to carry across the beam. My second question that I asked you guys was, what is the minimum thickness that the beam can be equal to? And this question actually solves both questions, the first and the second. So we're just going to solve it this way, and if you did it the other way where you substituted in all the values in and compared, that's fine. It's just you don't answer both questions at once. You're just answering one question at a time. So what I did first was since I'm trying to find the thickness, which is D, or the depthness, wow, that's funny, the depth, we would solve for D. So I'm going to solve for D. And this is essentially what I really wanted you guys to try and do, which was solve for the variable. So the first thing I'm going to do is I'm going to multiply both sides by L so that I get rid of that fraction. I know you guys don't like fractions. If we can get rid of fractions, it makes it simpler for us. So I multiply both sides by L. Next, I'm going to divide. I want to get D squared by itself so I can then square root it. And to do that, I divide both sides by KW. So now I have SL divided by KW equal to D squared. Now, because I have that square there, I want to undo that square. And to undo a square, I simply take the square root. So my answer is going to be D equal to the square root of SL divided by KW. Now is the time when you're going to want to substitute all the values you know. We know our K. We know our W. We know our L from the distance between the two buildings. It has to be a minimum of 25 feet. The only thing that we might not know is the S. Well, we get that from these 2 pounds here, the cart and the worker. And so if I add those together, my S is going to be 1,105. So I've got all 4. Now I just substitute them in. So D equals the square root of S, which is 1,105, times L, which is 25, divided by K, which is 576, times my W, which is 2. So solving this, I would now just multiply the answers that I'm given. So I have 11,005 times 25, which is 27,625, divided by 576 times 2. Oh, messing up on my calculator here. 1,152, so 27,625 divided by 1152. This is approximately equal to the square root of 23.98. Now I'm saying approximate because this answer is actually goes on forever. But what I do in the calculator is I leave my answer in the calculator and show the rounded answer on my work, so that when I finally solve this, I'm going to take the square root of the answer in my calculator, which gives me approximately equal to 4.8969, blah, 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 goes on forever. But it's kind of hard to find 4.89 inches or 4.897 inches, whatever you round it to. So make it a whole inch. So we're just going to say it's approximately equal to 5 inches. So if we make the beam 5 inches thick, that's the minimum width or thickness that the beam can handle, that safe load. The other thing is 6 inches thick enough? Yes, it is. It's an inch higher, an inch thicker than 5 inches, which basically means when we do 6 inches as our thickness, we're adding an extra inch in case we made an error, in case there's somebody who's heavier than 250 pounds, let's say. So that's our final answer, is that 5 inches that covers that. The minimum is 5 inches, and 6 inches is the extra that does cover it. Okay, so moving on to the next part, let's just talk about a few bits of information. When we're solving radical equations, we have to consider two different types of situations. If I have a square root of x plus 3 equals to 10, this is a radical equation. If I have x plus the square root of 3 equal to 10, this is not a radical equation. They both have a radical in them, but you notice in the left-hand equation, I have the square root of x. X is inside the radical. In the second, x is not inside the radical. So this is not a radical equation. So that's one difference between radical equations and other equations. So to solve these radical equations, we have 4 steps. The first thing is we need to isolate the radical. Just like when you isolated the variables in an equation, you're going to isolate the radical. Get everything away from the radical that is not inside the radical. After you get everything on one side and the radical on the other, you're then going to square both sides. Now, you're only going to square both sides if you have a square root. If you have, let's say, a cube root, then you're going to raise everything to the third power. If you had a fourth root, you would raise everything to the fourth power. Okay? Whatever the number is right here, that's the exponent that goes on the outside. Okay? So keep that in mind. You have to follow that step here. Oops, we're at number 3, not number 4. Third step, after you get rid of the radical on both sides by either squaring, cubing, fourth root, or raising it to the fourth power, or whatever the power is, you're going to solve the equation like normal. After you've solved the equation, you must check your answer. If you do not check your answer, I will mark you down for this. The reason being is not always will our answer be a correct answer. You might have done all the correct work, but that doesn't mean that the answer we find is the answer that works. we could get an answer that does not give me a valid equation. And I'll show you an example of what that looks like. One last thing that you need to keep in mind when you're solving radical equations is you do not want to square the terms. So you're going to square the sides, not the terms. And what I mean by that is, let's say I had x plus 3 equal to 5. If I square both sides, I would have, well, that's not really a good answer, a good example. Let me look at, let's say I had 4 plus 3 equals to 7. We know this is true, right? This makes sense. 4 plus 3 is 7. That's right. So if I square both sides, it should still keep an equal answer. I should still get the same answer on both sides. So let's just look. If I did 4 plus 3, that's 7, equal to 49. Is 7 squared 49? Yes. This checks out. If you squared the terms instead, so you would do 4 squared plus 3 squared equal to 7 squared. 4 squared is 16, 3 squared is 9, 49 equal to 49. 16 plus 9 is 25, which is not 49. So you see the difference here? When you square both sides, you don't square the terms. You have to square everything on the inside. And again, you must check your answers. Okay, so this brings us to examples. So if we look at a few examples here, I'm going to show you one. I'm going to show you a couple that are pretty generic, and then I'm going to expect you guys to take those generic and apply them to more complicated answers, because I got to keep it under 15 minutes. So let's say I have square root of x minus 1 equal to 2. First step, isolate the radical. I've already got that taken care of. The radical's by itself on the left-hand side. So the next step I want to do is I'm going to square both sides. And the reason I'm squaring is because I have a square root, not a cube root. So when I square both sides, the radical goes away, leaves me with x minus 1 equal to 2 squared, which is 4. Add 1 to both sides, gives me x equal to 5. So that's my answer, but I got to check it to make sure it's correct. So I substitute x equal to 5 back into the original equation. So I have the square root of 5 minus 1 equals to 2. So square root of 5 minus 1 is 4 equals 2. Square root of 4 is 2 equal to 2. Checks out. My answer is x equal to 5. It does work. So that's when I have one answer. You're asking yourself, well, can I have more than one answer? If you remember from algebra, yes you can. So let's say I have the square root of 2x plus 1. Let's say it's plus 5 equal to 2. So again, first step, isolate the radical. To do that, I would subtract 5 from both sides. So I get the square root of 2x plus 1 equal to negative 3. Next, I'm going to square both sides. So then I get 2x plus 1 equals 9. Next, I subtract 1 from both sides. I get 2x equals 8. Divide by 2, x equals 4. So that's what I'm going to check. So I substitute x equal to 4 into the original equation. I get the square root of 2 times 4 plus 1 plus 5 equal to 2. 2 times 4 on the inside is 8 plus 1 plus 5 on the outside equals 2. 8 plus 1 is 9 plus 5 is 2. 9 square root of 9 is 3 plus 5 is 2. But 3 plus 5 is 8, which is not 2. So x equal to 4 is not an answer. So this answer would have no solution. So this brings us to your multiple choice question. I suggest right now you pause the video, take a look at it. And here's your free response.